Trigonometry, Chapter 7, Applications of Trigonometry, Vectors, Section 2, The Law of Cosines, Video 6, Another Formula for the Area of a Triangle. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we took a closer look at the law of cosines to find an angle in a triangle. In this video, we use the law of cosines to derive a formula for the area of a triangle in terms of the lengths of the three sides. In other words, tell me the lengths of the three sides, I can calculate the area of a triangle, which doesn't sound like it involves the law of cosines. And do you remember that the law of cosines involves all three sides? Now, in order to keep this video length reasonable, not sure how this is going to go, I will outline the general steps in this derivation. To fill in the algebraic omissions, I recommend referring to any trig textbook, such as Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels, or searching a longer video about the derivation of Heron's formula, which is where we're heading. All right, follow me if you can. Step 1, expressing cosine of A in terms of the semiperimeter. Now, that's a new term, but the semiperimeter, lowercase s, of any shape is exactly what it sounds like, half the perimeter. So for a triangle whose sides are lengths A, B, and C, the semiperimeter S is the perimeter A plus B plus C divided by 2. Now, it's fairly straightforward to verify the following algebraic identities for the semiperimeter of a triangle. 2 times S minus B equals A minus B plus C, and 2 times S minus C equals A plus B minus C. I invite you to verify those, but we will use these in a moment. Now, one version of the law of cosines is cosine of angle A equals B squared plus C squared minus A squared over 2BC. Now, if we do 1 minus cosine of A, then we get 1 minus this fraction, and upon getting a common denominator, we get 1 minus cosine of A equals all of this. 1 minus cosine of A equals 2BC minus B squared minus C squared plus A squared over 2BC. Now, in that fraction, the numerator can be factored into A minus B plus C and A plus B minus C. And I should mention it's straightforward to distribute this to verify that it equals the numerator, but it's a different task to start with the numerator and factor it into A minus B plus C times A plus B minus C, but it does factor into that. This means that 1 minus cosine of A is equal to A minus B plus C times A plus B minus C over 2BC. Now, recall that 2 times S minus B equals A minus B plus C, and 2 times S minus C equals A plus B minus C. I mentioned that back here without verifying it. I invite you to verify it with the semiperimeter as that. But with those observations, we can now change the two factors in this fraction and get that 1 minus cosine of A is equal to 2 times S minus B times 2 times S minus C over 2 times BC. One of the 2's cancels with the on the top, cancels the 2 on the bottom, leaving us 2 times S minus B times S minus C over BC. Okay. Now, in a similar approach, you can show that 1 plus cosine of A is equal to 2 times S minus A over BC. And we will use both this and this in a moment. Step 2, expressing cosine of A over 2 and sine of A over 2 in terms of A, B, C, and S. Now we're going to have to go and dig some identities out. We're going to start with this cosine double angle identity. Cosine of 2 theta equals 2 cosine squared theta minus 1, but we're going to substitute theta equals A over 2, which will give us cosine of A equals 2 cosine squared of A over 2 minus 1. And if we add 1 to both sides, we get 1 plus cosine of A. The idea was to get this 1 plus cosine of A that we know something about. Now, since 1 plus cosine of A equals 2SS minus A over BC, then this becomes 2SS minus A over BC equals 2 cosine squared of A over 2. And then we can divide both sides by 2 and get cosine squared of A over 2 equals this fraction, and then square root both sides to get cosine of A over 2 is the square root of S times S minus A over BC. I know that's a lot. Bear with me. Now, we could also use another double angle formula. Cosine of 2 theta equals 1 minus 2 sine squared theta, with theta equals A over 2. to get 1 minus cosine of A equals 2 sine squared of A over 2. But since 1 minus cosine of A equals this fraction, remember we saw that back here, 1 minus cosine of A equals that fraction, that means that we get 2 sine squared of A over 2 equals this fraction, but the 2's cancel, and then we take the square root and we get this. Now, I'm about halfway through this video, and I see I'm hitting the 5-minute mark, so I'm going to actually break this into 2 videos. This will go down as part 1. For part 2, we're going to continue with step 3.